Chord. And nice clear pictures tonight, too.
Yeah.
All right, let's see. For problems 1 through 3, assume P is parallel to S. So I assume all of them are dealing with this figure over here?
Yeah, I think so.
Okay.
Well, yeah.
It looks like it, yeah. So let me just take a picture of this and start writing down stuff. So we know angle 2 is that, and angle 1 is that. Well, what do we know about angle 1 and angle 2?
They're congruent.
They're the same. Their measurements are the same. Yeah, they are congruent, which means the measurement of the angle is the same. Well, this one's saying that that one is that. This one's saying that one is that. It's hard for me. Okay, and over here he put a check mark saying, yep, you started the problem right. And I'm guessing you fell off at this step right here. So let's see. You moved everything over. What should this line be that I'm pointing at?
Negative.
Well, first of all, it's x squared. Definitely. 3x squared minus 2x squared. So that brings that term over.
Yes.
What are the... Okay, so that's negative 9x and plus 20. Now, factor... Can that be factored? Give me factors of 20.
4 and 5.
Good. Okay, so factor that.
Negative 4 times negative 5 would equal 20, and negative 4 plus negative 5 equals negative 9.
So that's the answer. So x is equal to what? In other words, we have to solve that equation at this point.
Doesn't look like it, no.
Well, we're trying to solve for x.
Oh, yeah. You have to do x minus 4 equals 0 and x minus 5 equals 0.
Okay, so what are the two solutions you get for x?
4 and 5.
Okay. Which means both solutions probably work. If I plug in x equal 4, I'll bet you that's true. Those are equal to one another.
Mm-hmm.
And if I plug in x equal 5, I'll bet you both of those are true. Usually when you're dealing with a polynomial and you're factoring it and you get two solutions, both of them are valid. It's only when you get to where you have radical signs or absolute value signs or logarithms that you produce a solution that might be extraneous. In other words, the rules of algebra merely say that you can't multiply two numbers together and get 0 unless one of them is 0. So we know one of them has to be 0. But both of them don't have to be 0.
Yeah.
And that's the key. That explains extraneous solutions when you get one. Now, clearly here the other answer is 5. And if you have time, and this is an important part, because all your tests are timed, right? I mean, you don't have an unlimited amount of time to answer these questions.
Yeah, all of them are 10.
Okay. So when you come up with these two answers, you got two choices. You can either list both answers or go on to the next question, or you can plug them in and see both of them if they're both valid. And I guess what I'm trying to explain is that if you're dealing with polynomials, they're both going to always be valid. I can't recall ever seeing a polynomial where both solutions weren't valid. In other words, this is not where you get extraneous solutions. So you're done. You come up with 4, 5, go on to the next problem.
Yeah.
Did you get this one right?
Yeah.
So we want to do 3.
Yeah.
Okay. Boy, I'm having a little troubles with this Windows ink space. The last couple days, it's been really slow. All right, so if angle 6 is this, and angle 7 is this, what's the relationship between 6 and 7?
Are they equal or no?
Yeah, let's talk about parallel lines and transversals for a moment.
Oh, yeah.
In other words, we have two parallel lines and a transversal, right?
Yeah.
I think I want to explain this a little bit more fully. Let me do this first, and then do this. I think this is really helpful in understanding parallel lines and transversals. They give you a lot of theorems to memorize, and you don't need all those theorems, not unless they're asking you for a 2-column proof. If I have two parallel lines and a transversal, that transversal creates 8 angles. It really only creates 2 angles, 1 and 2.
Yeah.
Every other angle is either 1 or 2. And the easy way to tell is it obtuse or acute?
Okay.
If it's obtuse, well then 1 is equal to 4 is equal to 5 is equal to 8. If it's acute, then 2 is equal to 3 is equal to 6 is equal to 7. And the other thing is that angle 1 plus angle 2 are always supplementary. That's all you need to know about parallel lines and transversals.
Yeah.
Now, in our situation, you are looking at what's the theorem? Alternative interior angles,
Yeah.
which are 3 and 6, and also 4 and 5.
Yeah.
1 and 8 are what?
Alternate exterior angles.
Alternate exterior angles. And so are 2 and 7. So they teach you all these definitions about alternate interior and exterior and adjacent angles and corresponding angles. Give me 2 angles that are corresponding.
8 and 4.
Okay. You get it.
Yeah.
In this case, we're looking, hold on, let me, excuse me. I have a bad cold, so I apologize for the coughing. So we're looking at that. Eliminate everything else from the picture. They're both acute. They got to be the same. So that's why he says put an equal sign there.
Yeah.
Okay, and then once you do that, then it's relatively simple to solve it. Let's solve it. So we got 2x squared plus 8 equals x squared plus 33. Give me each line. Give me the next line.
So that then if we were to move over x squared and 33, it would be x squared plus negative 25. I mean, no, yeah, it would be x squared minus 25.
Okay. Now, when this is a quadratic, and when you have a quadratic, there's a bunch of ways to solve quadratics, okay? This is particularly unique in that there's no x term. There's an x squared and there's a constant. So in this case, I've got two ways to solve it. I can actually put the 25 on the other side and now take the square root of both sides. What do you get?
X equals 5.
It's actually plus or minus 5.
Oh.
And that's
Yeah.
one of the bigger mistakes made in math. I would say 95% of my students make that mistake. They just don't remember the plus or minus. And believe it or not, both answers are valid. If I plug in plus or minus into that and that, they will be equal. So the answer is plus or minus 5. Now, let's go back 2 steps and look at a different way to solve this. This is definitely the preferred way.
Mm-hmm.
But there's a way that you can never make the mistake of forgetting the plus or minus. What is that called?
You could.
Difference of perfect squares.
Oh.
Factor that as difference of perfect squares. X minus 5 times x plus 5.
Oh, yeah.
Now, look, we get the two solutions we're looking for, and we can't even make a mistake. In other words, by doing it the way you originally wanted to do it, which was to put everything on one side, 0 on the other, that's rarely the bad way to do it. In fact, it's never a bad way to do it. We can always handle it that way. So I like your method actually better than my method, where I leave the 25 on the right side, because that leaves the chance that you'll make a mistake. And anytime you can do a procedure in math where you'll make less mistakes, that's what you want to do with algebra. Okay? Yeah. And this is all algebra here. All right. So again, a minus 5 is an allowable solution. Let's talk about that for a second. Could angle 5 be a negative number?
Angle 5 be a negative number? I don't think so.
No, it cannot be. All these angles have to be positive numbers. But it's not asking about an angle. It's asking about x. The angle 6 is this one right here. Notice that putting in a negative number for x, it squares, becomes positive, you get a positive angle. Same thing here. So it's okay to have a negative value for x. You just cannot have negative values for angles or dimensions. So when you're doing geometry problems and you come up and you're trying to solve for dimensions and you get a positive and a negative answer, you throw the negative answer out. But this is a little different. This is not the angle. That's just a value of x. So a negative value for x works here. All right. Scroll down. So we're done with that figure. Did you get this one all right? Except you forgot to simplify it.
Yeah.
Simplify this. Hold on. Let me give you a different one. See if you know how to simplify. Simplify that.
Let's see. 5 and no, it would be, so it'd be 2 times the
Here's
square root.
here's what you're looking for. You're looking for two factors of 200, and one of them needs to be a perfect square number.
Yeah.
That's the best way to do it. And in fact, the biggest factor you can find that is a perfect square number. You had it. You were going to say that, right?
Yeah.
Okay. That works because 100 is a perfect square number. It's 10 squared. So I can take that out, put it in front. There's my answer. Okay. Now, if I gave you something like this, simplify that.
Okay. Wait, so do you want me to turn it into like what?
I want you to simplify it. Simplifying it means always reducing. Pull any whole number you can pull out of square root of 40.
Okay.
And in order to pull a whole number out of square root of 40, you got to find a factor of 40 that's a perfect square number.
Yeah.
Okay.
4 and 10.
Okay. So we're going to write it like this. Okay.
Mm-hmm.
Now what's square root of 4?
2.
So 2 times 2 is 4. Square root of 10. Can square root of 10 be simplified?
I guess you could technically. You could do
Yes, but not really. In other words, simplifying it to square root of 5 times square root of 2 is not simplifying it. You're turning one term into two terms. In other words, in order to simplify a radical, you've got to be able to pull a whole number out of it. And you can't out of root 10. Root 10, the best you can do is root 5 times root 2. And so you don't do that when that's all the best you can do. The numbers you cannot simplify, root 6. You cannot simplify root 10. You can simplify root 8 because that's root 4. Excuse me, that's root 4 times root 2. So root 8 is 2 root 2. So the only ones you simplify are the numbers that you can pull a whole number out of.
Mm-hmm.
All right. Let me just look at number 4 for a moment. Looks like you got number 4 all right, except for down here.
Yeah.
It's a little hard for me to follow your work. And that's a little problematic. If it's hard for me to follow it, it's going to be hard for your teacher to follow it. And if it's hard for your teacher to follow it, he's not going to look favorably on grading it. So the solution is make everything in proper order so that your teacher can follow it.
Okay.
This is extremely tough to follow. Let's see. All of this blue writing is your teacher's writing, right?
Yeah.
Okay. How far is it from A to B, C? I assume the B is over here on the left. So that's the distance. In other words, that's what we're looking for.
Yeah.
Okay. I must be missing something here. How far is it from A to BC? What does this say here? 2.5? No.
It says 2.
Oh, 2 root, what?
Yeah.
2 root 2.
2 root 7.
2 root 7. Let's talk about solving right triangles. hold on one moment. I'm going to give you a bunch of right triangles, and I want you to solve them as quickly as possible.
Okay.
And trust me, there's no skill you'd rather have in math than solving right triangles quickly. I know that you know enough about geometry that you know c squared equals a squared plus b squared, the Pythagorean theorem.
Yeah.
But you don't always want to have to go back to that. You want a simple, straightforward way of doing it. What's the hypotenuse equal to?
The hypotenuse is equal to the square root of 12, which would then be
Hold on. Whenever you're solving a right triangle, always start your answer with square root of.
Okay.
Okay? It's always the square root of something. In this case, we're solving for the hypotenuse, so it's the square root of the other side's squared.
Yeah.
That's the quick way to do it.
Mm-hmm.
I don't want to always have to go back to this. If you always have to go back to this, normally in math I say remember one thing and if you can always figure it out from this. And you can. But with right triangles, you have to solve so many of them. And by that I mean you'll have to solve 200 of them in the next 3 years.
Yeah.
So figure out the easy way to do it, the faster way.
Mm-hmm.
Notice this solves for C by merely taking the square root of both sides. So that answer is square root of 13.
Yeah.
All right. I'm going to give you another few. Yeah, I don't need another page. Let me give you this one here. It's really only two situations. There's a situation where you're solving for the hypotenuse, and there's the situation where you're solving for an unknown side, one of the short sides.
Yeah.
Now, what's the quick and easy way to solve for y?
So you could say.
What's your answer going to begin with?
The square root of 4 squared.
Actually, when you're solving for a short side, then the first number is always the hypotenuse squared.
Okay.
There's subtraction taking place, and then it's the other side squared. Notice that if I go up to that formula and I solve it for A, I get A equals the square root of C squared minus B squared. Or if I solve it for B, B equals the square root of C squared minus A squared.
Yeah.
So those two formulas, along with that formula, are the quick and dirty method of solving right triangles. You don't want to always have to go back to this and algebraically manipulate it. It takes too much time.
Yeah.
If you only had to do 5 of them over the next 3 years, I would say just remember this and go back to it. But the fact is that there's very few things in math more important than solving right triangles. You have to do it hundreds of times, literally. When you take your SAT test, there'll be at least 5 problems on there that require you to solve a right triangle.
Yeah.
Okay? All right. Enough with the lecture on right triangles. So this short side right here, how do we get that? We can do it in one easy step. A to, I assume this is B over here. I can't see it. It's off my page. Has to be. Yeah. Okay. So what's AD's distance?
10. Oh no, no. It's 2 times the root of 7.
Let's call it by the way I just explained it. It is, and then we'll simplify it because you can read that as well as I can. I want to make sure you can do it.
Yeah.
So AD is what? Based on what I just explained?
It is 8 times the root of 2 squared, or
Hold
yeah,
on.
8 squared.
Forget that. Cover that up. Do it
Yeah.
the way I suggested doing it. It's the hypotenuse squared minus the other short side squared. That's what AD is. Okay? So if you do that math, you get 64 minus 36 square root of 28, which simplifies to 4 times 7, which is 2 root 7. So that's how he gets it.
Yeah.
And I understand why you almost fell for the oldest trick in the geometry book, which is to make it look like a 3, 4, 5 triangle. And that's why you first said 10.
Yeah.
Which is very good. If I gave you a triangle like this and I said 3, 4, it's very tempting to call that 5. Well, a 3, 4, 5 right triangle, the 5 has to be the hypotenuse, always.
Yeah.
It can't be one of the short sides. So this is not a 3, 4, 5 triangle right there. Even though it kind of looks like one. It's not, because the 4 side is the hypotenuse. And you always need the 5 side to be the hypotenuse, or a multiple of 5. These are it's a multiple of a 3, 4, 5, which is even easier to fool somebody with, because then you think, wow, I'm looking at a multiple of a 3, 4, 5 triangle, and they're giving it to me this way to see if I recognize it.
Yeah.
So it's easy to get people. I've fallen for that many, many times, trust me, where I see a triangle that looks like a 3, 4, 5 triangle, and it isn't. And so you have to do it the hard way. Okay, so that's correct. The length of AB, now that we know that and that, then that's going to be easy enough to figure, right?
Yeah.
Which you did. You figured it right. You just didn't simplify it. In other words, 32 is 4 times 8.
Yeah.
So that becomes 2 times 4 times root 2.
Yeah.
Excuse me. 32 is 16 times root 2. Notice that some numbers have multiple factors that are perfect squares. This one I could have said 4 times 8, but that's the slow way to do it. The fast way to do it is 16 by 2. And the reason this is better is you always want the maximum perfect square number factor. You're looking for factors of 32, you want the biggest one. That'll make your solution the quickest. If I use a smaller one like 4, then I'm dealing with 2 times root 8, and then I got to simplify that further, so it becomes 2 times 2 times 2 times root 2, and that's where the 8 comes from. But notice that if we do it the most efficient method, it's 2 times 4, there's your 8 root 2. All right, is there anything else on this problem we need to talk about?
I don't think so.
It's a little hard for me to see why you lost a half a point. I guess it was just merely not simplifying that.
Yeah.
That was the half point. Okay. What's the next page we want to look at?
Probably the second part of the test. So the one right next to test 5.
1, 2, 3, 1, 2, 3, 4, 5. Give me a number.
3.
Just did this one.
Oh, okay. Then
You might not be able to see these that well, so that's fine. But you will when I blow them up. Is this what you want?
No. I
Okay.
think, yeah. I mean, I'm looking at it, number 3, and I see there's a trapezoid and like drawn on it, and that's what's on my test.
Number 3, this being the middle one?
Yeah.
Okay, that's one we want to look at then.
Okay.
Okay, yeah, I see the trapezoid, okay. And, okay, let's start with this one. What the heck was that page yesterday?
Which, oh, like, the one.
I have never, in 8 years of geometry tutoring, have I ever seen questions that required nothing but words, no numbers.
Yeah.
That was the strangest thing I've ever seen for a geometry test.
Yeah.
Okay, let's look at this one. Now, like I said, these look a lot more typical.
Yeah.
All right, let's see. Draw a quadrilateral MASH. That is an isosceles trapezoid with legs MA and SH. So what do I know about this trapezoid at this point?
That it's isosceles, and
What does that mean?
that MA is congruent to SH.
Is equal.
Equal, yeah.
The measurement of it is equal.
Yeah.
Okay. So they're saying angle M. What does that mean about angle M and angle H?
That angle M is congruent to angle H.
Which means the measurement is the same. Notice these questions are all about measurement. They're not about congruency.
Okay.
So you can jump directly to angle M is the measurement of M is equal to the measurement of H. And
Okay.
I tell you what, at some point in geometry, stop using words like that. You just say M is equal to H.
Yeah.
Okay. All of this differentiating between congruency and equality gets a little old after a while. It doesn't really come into play anymore. Once you get to a certain point, then things are equal. Okay.
Yeah.
So angle M and angle A. Okay, we know H is equal to M, but what's the relationship between A and M?
They're supplementary.
Yeah, whenever you have a trapezoid,
Yeah.
the two angles in between the parallel lines, in other words, the base is always parallel. So if I look at that angle, they're supplementary. And if I look at that angle and that angle, they're supplementary. But that's it. And that's whether it's isosceles or not. In other words, if I had a trapezoid like this, same thing. That angle and that angle are supplementary. And that angle and that angle are supplementary.
Okay.
So it doesn't have to be isosceles for that to be true. That's just the case with all trapezoids. Okay, whoops, probably shouldn't have erased that, but that's okay. So that's why he gives you that formula.
Yeah.
Now, do we need to solve that?
I think so, because I got it wrong.
Well, that's because you didn't say it was equal to 180.
Okay.
But if you think we need to solve it, let's solve it. Give me the next line. In other words, solve this right here.
So we first want to distribute 2 to 3x and negative 7.
Just read the next line to me. That's all I need you to do.
Okay. So 6x minus 14 plus 13x plus 4 equals 180.
Okay, now the next line.
So then we could say 6x, no, not 6x, 19x minus 10 is equal to 180.
Good. Next line.
So then 19x is equal to 190.
Okay.
And so then x is equal to 19.
X is equal to 10.
10, yeah.
In other words, I'm going to divide both sides by 19.
Yeah.
Okay. So x equal to 10. It's relatively easy as long as you get this first part correct.
Yeah.
You got to get your original formula correct. If you don't, you got no chance of getting the answer correct. So you have to write your equation that describes this trapezoid. All right. Let me look at number 2. If MA is 10x minus 5 and hold on, that's A there, right? And that's H, yeah, okay. And AS is 8x plus 4, and SH is 9x minus 1. Solve for x.
Okay. So what we could do is
What kind of trapezoid is this?
what? Oh, this. Oh yeah, it's an isosceles triangle.
Okay, so what does that mean?
So we could go 10x minus 5 is equal to 9x minus 1.
Solve that for x.
Okay, so then it would be x is equal to 4.
Perfect. Notice we didn't need that.
Yeah.
It's completely irrelevant to this problem.
Okay.
The only thing we needed was that side's equal to that side. Why he put AS on there was probably just to try to confuse you. Believe it or not, teachers do that all the time. They want to make it a little bit harder. Okay. What am I missing here that I'm not seeing that should be on there? A diagram, a drawing.
Yeah.
Always do that in geometry, just because it always helps. So let's draw a parallelogram. Okay. So a parallelogram looks kind of like this. Both opposite sides are parallel. It's usually not 90 degrees. Some parallelograms can be rectangles or squares, but most parallelograms, when they're asking you problems about parallelograms, look like this.
Yeah.
And this is MATH. And it's giving you all these angles. And they want to find X, Y, and Z. So tell me where to start. I can't make out much of your writing here in terms of figuring out what you've done. So let's start it from scratch. What do I know for sure?
That m plus a plus t plus the measure of m plus the measure of a plus the measure of t plus the measure of h is equal to 100. No, not 180. 360 degrees.
Yes, but that's not the most efficient thing we know. What do we know about angle M and angle T?
M and T are congruent, and A and H are congruent.
Okay.
Yeah.
Let's write some equations. M is the same as T, right? So that allows me to say this. 10x minus 5y plus 3 is equal to t. 16x plus 4y plus 9. Now,
Yeah.
that is one equation with two unknowns. Can't be solved. So I need another equation. If I can come up with a second equation with two unknowns, then I can solve it as a system. Solve a system. Solve it as a system. Answers are nice. Not sure what that means.
Yeah, I don't know what that is.
Give me another equation that I do know. How is m related to a in a parallelogram?
Okay, so 10x minus 5y plus 3 plus 5z minus 3 is equal to 180.
That didn't help a lot because notice we introduced a third variable.
Yeah.
Now we got three variables and only two equations. We still can't solve it.
Okay.
We need a third equation.
So,
how about we go back and we use this that doesn't have a z in it instead of a. What is true about a and h?
they are equal.
That makes this a whole lot easier to solve. In other words, if a is equal to h, hold on a second, then h and m are supplementary.
Yeah.
Excuse me. Yeah, h and m are supplementary. So, plus h, which is 3x plus y plus 2 equals 180.
Yeah.
Now, notice I have two equations and two unknowns. And you can almost always solve that. Every now and then they'll throw in one that has no solution, but usually you can solve that. Okay?
Yeah.
Now, the best way to solve two equations, the best way to solve a system of equations is usually to put each one in standard format.
Yeah.
Standard format is ax plus by equals c.
Yeah.
So let's take equation number 1 and put it in terms of that.
Okay. So, negative 10x.
Combine all your x's, all your y's on the left side, all your numbers on the right side. That's standard format.
Sorry, I thought that 4y was next. Okay, so negative y.
Hold on, let's start with x. Always begins with x. We got 10x minus 16x. What's that?
Negative 6x.
Okay.
Minus y.
Minus 9y. You see why? I'm bringing that 4y to the left side, so I've got to change its sign.
Yeah.
I'm subtracting 4y from both sides. Okay. And then the numbers all go on the right, so what's the number?
6.
Okay. So I got this equation number 1 in standard format. Now let's do number 2 in standard format.
Okay.
Combine all your x's.
Oh yeah. Okay. So let's see. That'd be 13x.
All your y's.
Negative 4y. Yeah.
And all your numbers on the right side.
All my numbers on the right side. That would be 175.
Okay. So there's the system of equations that we have to solve. Now, once we solve that, once we know what x and y are, then it's going to be relatively easy to solve for z. Because we know angle A is equal to an angle H, and we'll know angle H. So solving for z will not be a problem. But it's better if we don't make it part of the solution for x and y. Because then we're dealing with 3 equations and 3 unknowns, and that's much more difficult to solve. 2 equations and 2 unknowns are relatively simple.
Yeah.
Okay? Now, let's see, I need some writing room here. So I'm going to erase this. We don't need this anymore. We've got our equations and 2 unknowns in standard format. We can now try to use elimination on them. So that's equation 1, that's equation 2. This is not an easy solution, but certainly doable. Most of tonight's problems are algebra problems, really. Well, not really. I guess we had to know how parallelograms work and how trapezoids work and stuff like that. But the real difficulty is in solving these equations.
Yeah.
So how are we going to solve this one? By elimination. Let's solve it by elimination.
So what could you multiply then?
Okay, think least common denominator. And am I going to use the 6 and 13 and try to eliminate the x, or am I going to use the 9 and the 4 and try to eliminate the y?
Probably the 9 and the 4.
Because they're smaller numbers. And we're looking for a least common denominator. The least common denominator there is going to be 72. The least common denominator over here is going to be 36. Hold on one second. Hello? Yes. John, I'm in the middle of a session. What can I do for you? I answered it just in case it was you. Ah, that's because her session isn't for another half an hour. I send it to you right before the session. It's a different number, no problem. It's a different number at every single session. So I'll send it to you at 7:30. Okay? All right. No problem at all. Thanks. Bye-bye. Apologize for that, Jonathan. I don't usually take phone calls, but if I suspect it's a later appointment, I do. You know, just in case they're trying to cancel or something.
Yeah, that's okay.
I don't know.
So,
they don't. You still there?
Yeah.
Okay. So we're going to multiply the top equation by what?
Probably, I think 4, right?
Okay. And we can multiply the second equation by what?
9.
Okay. Most people do a lot better with addition rather than subtraction. If I do what you suggested, I'm still going to have negative signs in both of them. They're both going to be negative 36y. Then I'm going to have to subtract them. Subtraction is necessarily harder than addition. So rather than do that, how about we multiply the top by negative 4 and the bottom by positive 9. So what's the top become when I multiply both sides by negative 4?
So that would be 24x plus 36y.
And I've got to do the right side by negative 4 also.
Equals negative 24.
Now multiply the bottom just by 9.
That would be 100, no, not 100. Yeah, 117 plus, minus 36y is equal to...
They didn't make this easy. Do you have a calculator?
Yeah, I do. 900 and So not
I don't think so. I'm multiplying that by 9. It's not going to be 900.
1,575.
Okay, now what do I need to do to these two equations in order to eliminate a variable?
Combined like terms.
You have to add them. You can add two equations always. If I tell you a plus b equals c and also x plus y equals z, then you can add those two equations such that a plus b plus x plus y equals c plus z. That's what you're doing when you're using elimination is you're adding or subtracting equations. And we've set this one up so that we can add them and a variable will get eliminated, the y variable. So what am I left?
So you're left with 117x plus 24x plus 36y.
Give me that answer. I know that we're adding them.
Okay.
What's 24x plus 117x?
141x.
Okay. Y's disappear. We don't have any more y's.
Equal 51. 1,551.
Good. You did that in your head, not on a calculator.
Yeah.
Okay, now you're going to need a calculator for this one.
Okay.
Maybe, maybe not. Looks to me like that might be 11.
Yeah, because if you had 100 and...
Well, it figures they're going to give you answers that are whole numbers. I don't know. Do you have a calculator? Do 1551 divided by 141.
I think it's 11.
Okay. Now, we're not done yet. We have calculated x. The question says, give me x, y, and z. We got 2 minutes left. We should be able to do all three of them. Which equation am I going to go to get y?
You probably would want to go to 6x minus 9y.
Yeah. Usually one of these two original equations are simpler than any equation we got when we multiplied both sides. So I go to the one that's got the smallest numbers. This one right here. Okay. If x is 11, solve it.
Okay, so that would be negative 9y equals 72, and so that would be y is equal to negative 6.
Negative 8.
Oh, negative 8.
9 times 8 is 72.
Yeah.
Okay, so now we have x and y. Now we got to figure out z. The only thing that has z in it are angle A. Well, do we know what angle A is?
Angle A
is the same as which angle?
Angle M. No, angle H.
Angle H. You can see it's not the same as M because I've drawn it. That's obtuse. That's acute. But those are both obtuse and they're opposite. And that's the definition of a parallelogram, is they're opposite angles. Okay. So I can say that 5z minus 3 is angle A is equal to angle H. 3x plus y plus 2, only I now know what x and y are.
Yeah.
X is 11, y is minus 8. Let's solve that for z.
So if x is 11 and y is negative 8, it would be 27.
Hold on, let's do it step by step. So 3 times x is 11.
Yeah.
So 3 times 11 plus what?
Plus -8.
Okay. Now we got one equation and one unknown.
Yeah.
Leave your z on the left, move all your numbers to the right. That's 3 minus 8 plus 2. I'm going to add 3 from the other side to get rid of all those. Now I got 5z equals 25 plus 5, 30. Z equals 6.
Yeah.
There's all 3. This was a little tricky because we put that third variable in there. So the secret to this problem was really trying to solve for x and y with 2 equations only, then going from there. If I put all 3 of them in there, it complicates this problem enormously. So,
Yeah.
Anyway. Jonathan, I'm going to let you go. Apologize for taking you a few minutes over.
Okay.
I will talk to you next time.
Okay, see ya.
Bye-bye.